Good morning, everyone. The example and with the sound like this. And the sound of the about running. Uh, so I finished marking your class. Later I can share some of the funding during tutorial time. But we cannot discuss the question yet because there's someone haven't take the exam. But one thing I want to say is, I'm not sure some of you want to get the answer, but you just provide the answer without the step. So I cannot give you marks. Okay. So the step is very important. If the step is wrong, maybe you can get more marks than just providing the answer. This week, I think, okay, so midterm is topic 1 to topic 3, right? So final will be mainly topic 4 to topic 7. So no more testing on the previous topic. But maybe you will use the language, but won't be focusing on topic 1 to 3. Another thing is, yeah, okay, so since we just finished an exam, this week will be a bit relaxing. So just do some counting. So you realize that our numbering is not following the chapter, so you have to find the right chapter in the textbook. So this topic 4 is corresponding to chapter 6 in your textbook. Okay. So first part, we will talk about products. Okay, so what's product rule? So suppose you got, hello. Suppose, yeah, suppose that you have a procedure that can be broken down into a sequence of 2 tasks. Okay. If there are n ways to do the first task, and there are n ways to do the second task, then there are n1 times n2 ways to do it. Okay. So what's the example? Okay, what's the example? So for example, okay, I think in okay, so for example, you know that in for example in D6, right? D6 you got this yeah, for example, suppose yeah, for uh, also, okay. So how many ways to make Allow. Okay. One. Yeah. So it allows to take one wedge and one meat. So how many ways to get it? Hmm? How many ways? So by another rules, there are 4 5 5 ways. Why? Okay, let's say we call it V1 out to V4, and then M1, M2, M3, M4, and M5, right? So in your dish, you will have V1, okay, V1, V2, either V1, V2, V3, or V4, and you can pair up with 5 times of it. So you will have altogether 4 times 5. It's like the Cartesian product. You take the Cartesian product of 2 sets. So one set you got veg, the other set you got meat. And then you take the Cartesian product, and then the cardinality of the Cartesian product is the product of individual set. Okay, product rules. So this chapter is very closely related to set. Yeah, talking about this product rule. So when I first came back from Australia studying, right? So because in Australia there are fewer Asian restaurants, and then their economic rice is just like eight choices, and then I never change the menu. Every day is the same. So, so my friend, my Asian friend and I always make fun of it. So when I first came to this Xiamen, then I saw the food store got like 80 choices. And not 50. All include the veg and meat. I go and count 50 different choices. And then I count if I take 3 dishes at once, how many possibility I have. So it's a lot, around like 50 to the power of 3, right? It's like 50 and 50 and 50. So it's about 10,000, right? So if I stay in Xiamen for 3 years, I don't think I can finish this combination also. Yeah, so I told my colleagues. Yeah. Okay, many minutes. That's why. Next is the sum rule. Okay. What sum rule? The task be done either in one one ways. So you have one ways to do one, and then and 2 ways to do the second way. And you don't want them to be the same way, so none of them are the same. Then N1 plus N2 equal to. Okay. So let us keep the same example, keep the running example here. So let's have the same setting. Okay. So let's say you want to be diet. You are on diet now. So how many ways to choose? MIS coffee. Choose one dish. That's it. Okay. So you can either pick B veg or you either can pick meat. So by thumb rule that 4 plus 5, which is 9 ways. Okay. So you can either pick B or you either can pick M. So it's like take the union of the set. Only one. Okay. Next. So next, we have seen it in the set theory. Just remind us again. Okay, before that, actually you can generalize the rule to the case of m greater than 2. So meaning you can have n1, n2, n3, n4 up to nm ways. So you can add all of them to the feature that there is no intersection. Similarly, for the product, you also can generalize to m greater to n case, greater than 2 case. Okay. Okay. Then the next one is called the exclusion of consent. This one we have then covered. But let's see what's the meaning of the formula last time we had. What we had last time is A union B, again, is equal to A plus B minus A plus A. So what's this called here? It's called the subtraction rule. Okay. So if a task can be, just now we exclude the possibility of intersection, right? Now we don't exclude the possibility of intersection. So we count all the possible way, then we take away the intersection number, the number of intersections. Sorry. Yes. Eight. And okay, this one we have seen last time already. Yeah. Then the next one is called the pigeonhole. Okay, so what's the pigeonhole principle? Maybe I draw some picture first. So let's say we go 1, 2, 3, 4, 5, 6. So we got 6 holes here. Okay. And then let's draw some pigeon. Maybe I draw like this pigeon. Yeah. So let's say I got 7 pigeon here. 1, 2, 3, 4, 7. So the claim is there must exist at least 2 pigeons in one hole. Okay. So you can imagine one pigeon occupying one hole, right? And then the last one have to go one of the hole. So if there are more pigeons than the hole, okay, then 2 of the pigeons must go to one hole. Okay, so this is the pigeon hole principle. So if given the integer, positive integer, and the k plus 1 or more are placed into 3 boxes, then there is at least one box containing 2 or more objects. Okay? Yeah. Pigeon hole. And next. Any question on to pigeon hole? On the products of the okay, yeah. So now we will do some permutation and combination. So what's the permutation? In permutation, we not just choosing objects, we care about the order. So permutation of the set of distinct objects is an order. Okay, so what's the permutation? For example, 2, 1 is permutation 1, 2. Okay, so when you sort the first and second coordinate permutation. Let's take another example. And R permutation is an ordered arrangement of R elements. So what does this mean? So for example, let's look at 2 permutation of the set 1, 2, 3. Okay. So what do we have? So in this set here, if you want to do 2 permutation, this means you need to pick 2 elements out, and then we care about the order. So what's the element here? We have what? 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, and 3, 2. Okay. So we pick R elements and then all the possible order we need to consider. So in this case, what is the possibility of getting, what's the cardinality of the set? 6, right? So how should I write it? Okay, that's right. The cardinality of percent 6. So can you come up of a way to count it? Can you come up with a way to count it? Huh? Right. No. It's 3 times 2, right? Because in the first spot you have 3 ways, and then the second spot you have 2 ways. Left with 2 ways, right? So first spot you can put 1, 2, 3, and then the second spot you left with 2 choice. So you have 3 times 2 ways. Okay. Yeah. So in general, what you have? And what do you have? So in general, how do you count it? If n is positive, and then there are, okay, let's put this. There are, so we use this notation here, P and R, which is n minus n times 2 up to n minus r plus 1. Okay. So this is the general formula. So, and that's the so how to prove this? Exactly by this proof sketch, not just proof sketch. So what's the idea? Just use the product rules. So you count how many ways you can do the first task and then do the second task. Right? So the small example is this one. Okay. So the general idea is n minus 1 and stop until this many times. By product rules. Okay. So in this case, you got, just in case you blur. So here we got R spot. Okay. Start with n. Okay. Please ask, don't be shy if you are unsure. Any stupid question are allowed. Otherwise, you will start on some stupid question, then you're confused. Okay. So remark here. So there are few ways to write these notations. So at least I know it's this one. So this is the same number as this. I think I heard from not your, but the other class. Use the Chinese background, right? So you write something like this. Is it true? True or not? True. Okay. Yeah, because I saw this in exam as well. I saw this in exam. So I was confused. Why you write something that inverted? Then I don't know why you're writing. Yeah. Then luckily yesterday the student told me was this week. So yeah. So to standardize, maybe we use this kind of notation. Yeah. Yeah. Standardize, we just use these two notations. Yeah. Okay. No. Okay. Happy with this theorem and the proof? Yeah, just use product rule, and then you got n r spot, and then you got n choices. Okay. And then you count to the last one is actually n minus r plus 1. It's a good practice if you want to write down the proof. So correctly, there's another way to write this down. Another way to write this down is P and I is your textbook notation. N factorial over n minus r. Okay, so this is the notation where what is n factorial, to remind you, is m times n times n minus 1 times n 2 times all the way up to 1. Okay. Is this formula obvious or not? It's obvious, 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 obvious. So after n minus r, so the next term is n minus r, right? So all the term behind get cancelled by n minus r factor. So you left with the, it's obvious. Okay, let's go. Again. If you're not obvious, please shut up. Not obvious. Okay, permutation, we care about orders. What if we don't care about orders? Then it is called a R combination. Okay, R combination is unforwarded. Okay, so let's keep the same running example here. So let's put this example there. Okay, let's change this question to com. Okay, so in this case, our set would change. Okay. So what's the way to pick 2 elements out of 3 element set? So we got 1, 2, 2, 3, 3, 1, or 1, 3 is the same. Okay. So in this case, we have 3. So notice that I changed the notation here, right? Just now I put round bracket, okay? Now I put set bracket. Remember that we define the round bracket as the ordered pairs. So the order is important. This is called the ordered pairs. Let me check it. Ordered pairs. Okay. But now we put here set notation. Okay. Remember we said that set, inside set, we just care about what distinct element is inside. We don't care about the order. Okay. So that's why we use set here. So permutation, usually we use round bracket, and then combination we use set bracket. So what's the cardinality? Cardinality is 3. Okay, so in general, how do you count this cardinality? Let me write down the formula. So here, this one. The number combination set with n element where n is the possibility given and such that D and R, okay, which is n factorial over R factorial. Okay. So when you see this formula before, I think you all see it before. Do you ever think how this formula comes from? Why is it n factorial over r factorial times n minus r? Ever think of it? How it came from? You wonder why? So what is DNR? So how to relate? Can we relate it back to PNR? So the claim is if you want to permute R elements from an N element set, actually you first pick R of them up, right? Okay, you don't care the order, you pick R of them up, and then you do permutation on R elements, okay, which is PR. Yeah, right? So let's come back here. So for example, in this case, this is P3R, P3R, P2R. Okay, so P2R. First, you pick two of them out, and then you do the permutation. Then you will get all the permutation. Right? So this is how you prove this theorem. Okay. So because we know that the right hand side just now by theorem just now by theorem so by theorem before we have PNR is n factorial over n minus r factorial. Okay, good. And then what's about the PRR? So it's r factorial over r minus r factorial. Okay. So what is r minus r factorial? 0 factorial. 0 factorial is 1. This means which means CNI is equal to n factorial over r factorial n minus r. Okay. Okay. So this is how the formula come from. Okay. Okay. From here, we can actually see some property of this number here, this set of number. Should I do remark first? Okay, maybe I do a remark first. I'm also okay. This notation, these two notations. So n choose R, and then expert notation. So n choose R. So, so looking at this, if you stay long enough in this formula here, stay long enough, then actually you can notice that. What do you notice? So you notice that actually CNR is equal to CNN minus R. Okay, so what does this mean? So this means, for example, C what? C63. Okay. C63. Okay, C63 is not fun. Maybe C52. Okay. So C52 is equal to C53. And then C51 is equal to C54. Then C50 is equal to C55. Okay. So this is something we call like a duality. Some duality phenomenon. So what's this? So if you like arrange them, right? You arrange them like this in our order. Then you see that there's like symmetry like this. Okay. So the outermost is the same, and then you, I mean, because I'm algebra person, so I like this kind of symmetry. Okay. Symmetry in this. So this means if you know about C51, you actually don't need to compute C54 again. Actually, they are the same. So if you know C52, it is actually C53. You don't need to compute C53 again. So that means you just need to compute half of the number, then you can get the other half by the symmetry. So is it easy to see this? Is it easy to see this here? Can anyone see this equality? Hmm. Anyone see the equality? YCNR is equal to CN minus R. Hmm. Hmm. And S10? Yeah. Oh, S10. No need S10. No need. No need expansion. Actually, you just sort. Just sort. Just sort. Okay. Yeah. So you just sort. No need expand. Just sort. Okay. So you see, you sub the n minus r here, and then you sub n minus r here, and then what is n minus r? Which is r. So this is the r. Okay. Clarity. This is the r. Okay. So just swap the what is that? The denominator. Okay. Yeah. Yeah. So use this number in my thesis. Okay. It's 9:40. Less than 1 hour. Okay. Next. Maybe we'll finish class earlier. I don't know. Okay, let's see. Yes. Okay, okay. Okay, actually this number appear at different places. So one places is called the binomial coefficient. Often denoted by which also known binomial coefficient. Right? So what is it? What is it? Binomial coefficient about? So let's look at this example here. Okay. So for example, x plus y squared. Okay. So what is x plus y squared? It's actually x squared plus xy plus yx plus y squared. Okay. Which is x squared plus 2xy plus y squared. So the binomial coefficient is the coefficient of this monomial. So for example, in this case, we have 2, 0 and 2, 1 and 2, 2. Okay. So 2, 0 means how many ways to pick x squared. And then 2, 1 means how many ways to take the product contain 1x. And then 2, 2 means how many ways to pick product that doesn't have x. Okay. Uh, so in this case, 2, 0 is 1. and then 2, 1 is this one. 2, and 2, 2. Okay. So why is it binomial? Because we got two monomial here. Binomial. So this binomial not just helping you to calculate square, it also help you to calculate all the powers n. Okay. You can calculate all the powers n and predict all the coefficient here. So should I? So for example, you want to compute a larger number, right? Then you compute a larger number. So instead of you expand this up like this, which take a lot of time, you just use the binomial coefficient, which means you get there's one formula I forget to keep. So from here, I think you should generalize this segment here to n. You should generalize by formula x plus y. Okay, so what does this mean? So if you expand this out, you will get 4, 0, x4 plus 4, 1, x1, x2y, 1, 2, square, y square, y, and then plus 1, 4, 3, x1, q plus 4. Okay, so how to compute the binomial coefficient? You just use 4 choose 0, then 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, and already tells you the formula here. You just plug it in and then compute. And then you will get, well, in this case, you get 1, 4, 6, 4, 1. Okay? Actually, you also don't need to go to compute the factorial thing. Actually, there's a identity here called the Pascal identity, which is the which give you the Pascal triangle. So in formula, it was stated as n plus 1k equals to nk minus 1 plus nk. Okay, so before we verify this identity here, let's try to use it. So you see this one is starting from when both of them is greater than 0. So why? Because when n equals 0, k equals 0, okay. I think this one is by definition 1. Okay. And then how about 1, 0? So 1, 0 is 1, right? Because it's the empty set. You pick nothing from one set. And then 1, 1 is just one way to pick one thing. So it's 1. Okay. And then how about 2, 1, 2, 0, 2, 1, and 2, 3? So let me see. Yeah. So 2, 1 is also 1 because everything choose 0 is 1, right? Because it's like empty set. You pick nothing. And then 2, 2, there's one way to pick all of them. Okay. So how about 2, 1? 2, 1, we can use this formula to get it. Okay. So 2, 1 is equal to n So n in this case will become 1. Okay, let me write down. 2, 1 is equal to 1 plus 1, 1. So by the Pascal, you get 1, 0 plus 1, 1. Okay? So that means these two will make out the number, which is 2. Okay? And then similarly, you can go to the next row, compute the Pascal triangle. So this one is 1, 1. And then now to compute 3, 1 is 2, 0. So 3, 1 is 2, 0. Sorry, 3, 1. Sorry. 3, 1 is 2, 0 and 2, 1, which is this one. 3, 2 is n minus 1, n plus 1 become n, okay, and then k, and then n minus 1. So become 2, 3. So if we just extract this triangle out, we will get 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Then you can keep going. Okay. So this is a quicker way, and you don't need to use calculator. So I already quickly write down up to like expansion of 6 here. So this one is like telling you about the 6 expansion, 6 power expansion, the coefficient for 6 power expansion. And then yeah, this one really quick. So this one is like and then I also learned that this one in long ago China also encountered this. It's called the Yang triangle. I learned that the Chinese, they you guys never learn Pascal triangle, right? Just learn Yang Hui. That right? In your syllabus. Is that right? Yeah. But I learned about this Yang Hui triangle only like 2 years ago or last year. Previously, I was like taught the Pascal triangle. To be the same with the other Malaysian Pascal triangles. I feel yeah. And then only 2 years I also come across this. So like I put this in my website. Copy this. This is the all-time Pascal Chinese. So actually, in different civilization, also look at this the same combinatorics number. I think India also got, but not learned from Wikipedia. Okay. Okay, this one is again. Later we come back from the break and then we try and prove this Pascal identity. Let's break until 10 o'clock. Yes. 那个考试多久出来？成绩的问题。成绩哈，成绩啊，
成绩我刚改好你们班吧，我刚改完你们班。
改完了。
你们班。
全改了。
你们班？
全改了。累死。
我差点吐血。
那成绩说
啊？
今天公布。
今天公布。可以啊，可以。什么？没有，这个只是一个 raw score 罢了，因为他们之后还会改啊。大概吧。
还要改。
就是可能之后我不知道会不会给你们再看过一遍啊，如果看过一遍，可能有一些调整啊，还是什么，然后之后呢又要大调整啊，什么之类的。就大概吧，就大概。
最高到。
我不知道 normal 不 normal， 那个 standard deviation 是14分。不是 standard deviation。
最高。
sigma 那个 sigma 哈。
最高分是多少
？83。应该是从一半出去一个 standard deviation， 然后是14。不是。
怎样讲那个14分？
我感觉是那个科是很肥耶。
哦，你是说这次考完吗？
啊。
Standard deviation 是14分。
Standard deviation 你知道吗？那个 sigma。
就是最高和最。
不是。他讲那个 normal 吗？
是那个一个嘛。
会就是说会的就很多，不会的就错很多。至少2题啊。
最高才8分。
个位数啊。
没有，
大多数多少分？
大多数应该是5、6、70这样。是有6、7挤在那边。
大概懂，反正不可以直接拿的。
啊？
反正
不可以是这样的。我觉得 OK 啊，我觉得 OK。我觉得真 OK。
我那时候做的
80多啊？
老师那个2N 料题不是超纲的，我们今天讲的。
2N。
对啊，你看那个赛对，可以有多少个参赛？
对。
就那玩意儿，今天讲。
怎么说？
没有，他是想到用这个。
我有看到有人用这个，但是
如果这个的话，
但是你也要证明说这个是能够算。对。
所以我就觉得。
对啊，你明白了。但是有人写对，有人满分那题，我不知道是谁忘记了，但是有人满分。standard 的答案呢？
还有人是标准答案。
标准答案。不同的学生有对不同的满分。
老师，如果第一题不是那个突破吧，我没有讲第8的话，会拿这个。
这讲5就1分哦。
就1分
啊？你都没有解释。我还没有给啊，我还没有给。对啊，要写理由啊，怎么可能3分没有步骤？
我在想这个突破是这么高吗？
对啊，我那边写了要解释啊，我那边有写。
不是，我当时说这没干啥意思。
啊？
我以为他就是验证你的答案，我就寻思触碰。没想到回去查了一下，他是解释说明的意思。
哎呀。
看到哪地方？
我回去问他，他说我来了。
我这最他问我了。我都有写，我都不能想到一些。
提早上我们可以讨论分数。如果提早上我们可以讨论分数。你们班呢？
太好了，先给我们班，
因为你们第2年嘛，对不对？然后我觉得应该你们答案不会太乱七八糟，是有点改。
你是讲我们班有了那个2跑来拿吗？
有。
那标准答案应该用多少？
就你 你 n 加一个吗？可是你要先想象你里面的 subset 是长怎样的。它有些会 contain 新的那个 element， 有些是旧的吗？不直接，就是你有 n 加一个东西嘛，但是你知道 n 个有多少个，对不对？combination 是，没有，但是我现在是说你怎么数嘛，对不对？你想不是用这个方法，你就想它是长怎样的，它的 subset。你想，我不然我画给你看。课本里面有，课本里面有啊。
我觉得这个人比较原理耶。
啊？
课本里面有一模那个背景。
有哈。
也是藏的有点深啊。
OK。喷有在吗？喷有在吗？喷子健有在吗？喷子健有在吗？没有在哈。没有在，我们可以讨论。等一下，我们讨论。等下可以讨论。子健没有在，我们就可以讨论。罗一飞是谁？有来吗？这个是国一飞啊。他干嘛？刚醒啊？刚醒，这么爽，我也要刚醒。我本来想今天就躲在家改房间，就不要出。啊？
我哪里啊？所以，你看老魏会是白啊？他为什么请哥让你记住他？
谁？等一下我会讲。
我想要随便那个。连想都没想到。
有人没有用，你拿先到哪里？
用啊，肯定用。
有人没有用，他直接 N 个一起做也可以啊，反正因为我没有说要把你打成，你能直接做啊，
直接就你，
直接就就他 N 个一起做算是。
啊，我知道了。
就是今天找一个。
还有人最后一题那个 Chinese Remainder 就直接给我拿号码来试，因为只有50个号码，只有50个号码就在那边试，把那个号码试出来。下次我的 range 要出大一点。啊，有啦，有分啦。因为我说200到250之间嘛，他就50个数，然后就全部给我来试。因为你只要找得到可以约整齐的，然后会越来越少。但是我的人要大一点，太少了。啊？
这样会得分吗？
可以啦，因为我没有逼你用 Chinese Remainder，除非我题目说要用。Okay, let's come back. Right? And then this. Okay, keep continue. So yeah, so if we finish class earlier, then we can discuss a bit on the scores in this class.
PR, what is PR? So, yeah. So how to prove this? Any idea how to prove this? Theorem here. Okay, so proofs. Just do it since we got a lot of time. So use algebraic relation. Okay, so maybe we start from what's this right hand side? Yeah, right hand side. So start from right hand side, we have n factorial over k minus 1 factorial times n minus k plus 1 factorial plus n factorial over k. Yeah. So what you want to achieve is n plus 1 factorial over k factorial times n plus 1 minus k squared. Okay, can you see some similarity between these two? So you need to make them into the same denominator first. So you can see that this here is this here is contained here, and then this here is contained here. So this means you need to keep this two, okay? And then so that means you need to make them into a k factorial first. So you add the k factors, right? So the k minus 1 factorial becomes k factorial plus with n minus 1 times n minus k plus 1. Okay, so you pack them into the same denominator now, and then you just add them together. Okay, can you see it? K n factorial plus n minus k plus 1 times n factorial. So what you have is this k cancel with this k, so you left with n plus 1 times n factorial, which is n plus 1 factorial. Okay, can see it? I need to expand. Need to expand or not? Or you can expand yourself. Try expand yourself. If you can't see it directly, you try expand yourself. Hey, what happened? Up. Okay. Delay. Sorry, delay. Okay. So okay, just now I repeat again. So okay, after you make it into the same denominator, right? Yeah. And then you add up the numerator. So here got a k times n factorial factors, and then here got a minus k times n factorial factors. So they'll cancel out. And then what you left with is n plus 1 times n factorial, which is n plus 1. Okay. If you can't see it, you need to expand it out to help you see. Okay, finish counting this chapter. Finish. Yeah. Okay, next chapter. We're going to the next chapter. Next chapter is more interesting. So yeah. The next chapter is relations. Okay, this one is more interesting than this one. Pay more attention to this one. One relations. Okay. I think we already talked about a brief idea of relation last time. Because when we talk about propositional logics, we want to relate to different proposition. We talk about set theory, we want to relate to different what? Set again. So what's the real definition here? So suppose we got two sets. Suppose we got two sets. A binary relation. So binary, because we got two now, binary relation from A to B is actually a subset. Again, subset of what? Subset of the Cartesian product of A equals B. Okay. So when you talk about relation, you need to have two sets. Then you talk about the element inside this two set. So a binary relation is from A to B is actually a set R, let's call it R, of ordered pairs. So the order is important here. A and B being an important different relation. So we will write ARB to denote the ordered pairs in R. The set, again, R is a set. Remember, binary relation is a set. If it is not A is not related to B, we write not in the set. Okay, so example. This example you all already seen before already. So first example is functions or graph. Okay, graph as relations. So what do you have? You have like x and fx. Okay, so x is in your domain, and fx is in your codomain. You have notation. So I write D1 and D2, different domain. One is codomain, one is domain. Okay, graph. Right? Graph x and fx. Okay. So how you link x to fx is the graph. Okay. The next two. Yeah, two. What have you learned? Okay, you just finished learning last week. Exam just finished, right? Congruence. Congruences are also relations. Okay. So for example, yeah, just pick up. Ah, okay. Yeah. Wait. So, okay, congruence as a relation. So, for example, in okay, you want congruence what? Congruence, maybe congruence 7. Yeah, we keep congruence 7 as the running example. So, congruence 7, congruences as a relation. So, in congruence 7, who are the same? Who are related? So, for example, 0 and 7 are related. 7 and 21 is related. And then 8 with 22 is related. And 9 with 2 is related. 16. Is it 16? 16. Yeah. Are related. Okay. So they relate two numbers together by modulo m, congruence to each other. And also, before congruence, you learn divisibility, right? So divisibility are also relation. Okay. So when are they relation? If A divides B. So for example, 2 divides 4, okay? And then 3 divides 9, and then whatever, what else? 10 divides 100. Okay. So there's a way to relate two numbers. So these are all the relations. These are our called relations. Okay. Do you have any example of relation? So far like this. There are more, but just keep these 3 first. Okay, but I haven't told you what's set, right? What's the set here? So the set here is these are relations from D1 to D2. These are the relation from Z to Z. And then this is a relation from Z to Z as well. Yeah. Yeah, that's one thing in your exam actually. So when we talk about the divisibility, right, some of you write fraction. Actually, I think we only define the divisibility on integer. But maybe I just give mark if you write like something like 4 divide. What did you write? It is something like this, 5/3, something like that. Okay, so I think we never define something like this, but I also let you pass this time. But next time you should pay more attention like where this number live in when I introduce the motion. Okay. Our divisibility only from Z to Z, not on the real numbers. Okay. Because for example, 4 divides 4/3, but we don't introduce this kind of nothing. Okay. So be careful on what you write. Pay more attention to the motion. Okay. So the thing we're interested in today is actually a relation on a single set. Okay. Relation. Okay. Now we will talk about relation on a set A. Because previously I said the binary relation is on two set, right? But now I talk about relation on set A is a E. Oh, okay. Here is a binary. Okay. So it's actually a binary relation from A to A. So the binary relation is a subset of what? Subset of A cross length. Okay. So next. So there are three important property of relation that we want to focus on. The first one is reflexive. Reflexive. So reflexive is like coming from the root word is like reflect, reflection, reflect. Yeah. So reflect to yourself. So it's about yourself. So a relation is called reflexive if AA is in your relation. You and yourself is in the relation. So for example, okay, let's run through an example first, then later on you pass some. In the congruence world, okay? Congruence, we keep the example mod 7. Okay? Is you and yourself inside this relation? For example, is 0, 0. Is 0, 0. 0 congruent to 0 mod 7. Right. So this is true, right? And then 2, 2 is also congruent to mod 7. So you and yourself is in the relation. Okay. And then second, second. So it's the divisibility. So you want to ask yourself whether you and yourself is in the relation or not. That means whether A divides A or not. Okay. So A divides A, right? Because A is equal to 1 times A. Okay. So this means you divide yourself. There's 2 divide 2, 3 divide 3, and so on. Okay, don't put 3 from 3 divide 3 from 3. It's on Z only. on that, okay. So let me ask you a question again. What kind of graph satisfies, let's see. Does this look like quiz type question? What kind of graph satisfies reflexive property? Huh? Y equal x. Y equal x. Okay. So yeah. Y equal x. Why is it y equal x? Okay, when we talk about function, right? Maybe now we don't talk about y equal x anymore. We talk about fx equal to x. Yeah. Because we want to have a function in our mind. And we don't put y, we put fx equal to x. So why is it fx equal to x? Because you want AA, you want AA is in your relation. That means AA have to equal to AFA or OA in your domain A. Okay? Which implies A have to be equal to FA or OA, which is fx equal to x. But there's only one function that satisfies this reflexive property. Anyone confused or not? This one. Reflexive property. Only one kind of graph. Which is the identity function. This is the identity function. Okay, fx equal to x. Okay, next. Next definition. Relation. That A is called symmetric. Okay. Now it's talking about you and the other guy. So you and different person. So if B and A is in the set, then A and B will be in the set. Or if A and B is in the set, then B and A is in the set. Okay. And then together, I want to introduce another definition, which is anti-symmetric. But note that these two, okay, note that these two are not negation of the other. Let me say it first, and then you will see. So what is anti-symmetric? If AB is in the set, in the relation, and BA is also in the relation, then this will imply only A is equal to B. Then this is called anti-symmetry. Okay, notice that these are not negation of each other. That means you can be both. You can be not symmetric and also not anti-symmetric. Okay. And you can also be, yeah. And then what this mean is if AB in the set, then BA is also in the relation. Right? Then remember. And then if for anti-symmetric, if AB is in the relation, BA in the relation, then A will equal to B. Okay, let's see some example. So, for example, the congruence mod 7. Okay. So the question is, if A congruent to B mod 7, then B is congruent to A mod 7. Is this true? Yes, right. Because because 7 divides A minus B imply 7 divides B minus A, which is minus A. Okay. So that means if AB is in your mod 7 relation, then BA is also in your mod 7 relation. So congruence mod 7 is symmetric. How about divisibility? Does if A implies B, then B divides A? All right, false. This is like the first question in the exam. False. Take 2 divides 4. Okay. So 4 does divide 2. So that means divisibility is not symmetric. But divisibility is anti-symmetric. Why? Because you can prove that if A divides B and B divides A, then the only possible way is A equal to B. And try to prove this. You can prove this. Okay. Next. Next is about transitive. Okay, transitive is about talking about relation between 3 elements. So if A and B is in the relation, okay, and B and C is in the relation, then A and C will be in the relation. Okay. And then A and B together, B and C, is there any relation between A and C? Yes, A and C is in the relation if the relation is transitive. So it's like you can transit to different person. Okay. So let's see. For example, let's continue the congruence modeling. Angle 7. Sorry. If A is congruent to B mod 7 and B is congruent to C mod 7, is it true that A is congruent to C mod 7? True. True, right? Because me to write out. So 7. So the question is 7 divides A minus C. Okay. But 7 divides A minus B plus B minus C, which is this is equivalent to this one. Equivalent to 7 divided A minus B plus B minus A, but by assumption you can divide these two terms, then there's a theorem that you can divide the sum of them. Then similarly, you can also, if you still remember, the divisibility theorem. So if A divide B and B divide C, then A divide C. Remember this one? If you don't remember, you can look back. That's why I easily like see this theorem because I know that the divisibility is transitive. Sensitive. So first relation we want to care about reflexive. So whether you and yourself is in a relation or not. Second, symmetry. If you with another person is in a relation, and then you swap the order, whether it's still in your relation or not. Symmetry. So symmetry is like the car, you cut into half. So left and right is symmetry. And then transitive. So whether this relation can transit or not. So if A, B is in a relation, B, C is in a relation, so you can go from A to C through B or not. If can, yes, then transitive. Okay, these three properties very important. So if everyone is okay with these three properties, then we will jump into a new concept called the equivalence relation. And this special relations is very useful. So what is it? Equivalence relation. So a relation on a set A. Okay. So first we define the binary relation, right? So now we talk about relation on just one set, which means it's a binary relation on A cross A. So it's called an equivalence relation if it satisfies three properties. So if it is reflexive, first reflexive, symmetric, and transitive. So you and yourself is in the relation. If A, B in the relation, B, A is in the relation. If A, B, B, A, B, B, C in the relation, then what? Then AC is in the relation. Okay. Okay, good. Next. So when we say two elements A, B, and B, that are from this definition, the one I'm writing down, you will see that why we are care about equivalence relation. So if two elements are related by equivalent relation, they are co-equivalent to each other. Yeah. They are not equal on the norms, but they are equivalent. Okay. Remember the last time we talked about this kind of concept. So for example, the congruence mod 7, okay? Congruence mod 7. So we will say that 0 is congruence to 7. Right? Or we write something like this. Remember the notation. Okay. But we cannot write screen. We cannot write 0 equal to 7 more. We cannot write like this. Right? Because they are not equal on the norms, but they are equivalent up to mod 7. Okay. So we write like this, or like this. Okay. Equivalent. Different thing, but they are equivalent under some rules of relation. Okay. They are not equal on the norms, but they are equivalent. Okay. And so do you need another example or not? Never mind, we just skip through first. The next one is actually this set, right? They form a class, form a set called the equivalent class. Equivalence relation. Okay. Suppose we got a equivalent relation, then we can collect all the elements that are related to an element A is called the equivalent class. So it's a set of A. So the equivalent class of A with respect to is denoted by. Okay, your textbook use square bracket A. Sometimes I will just write A bar. Okay, it's a set. So for example, I claim that in the congruence mod, it's mod 7. Okay. We got 7 equivalent classes. Okay. So there are 7 equivalent classes. Okay. What are they? They are like 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar, 6 bar, 6 bar, and 7 bar. Okay. And then what is contained inside this set here? Yeah, 7 bar. Ain't no 7 bar, right? Okay, why not 7 bar? Because 7 bar is equal to 0 bar. Okay, but this one you can show by set. Set equal. Yeah, equal by set. Okay. So that means if you go again, you will go back to this side, the cycle. Okay. Next. Okay. So so what's contained inside 0 bar? All the multiple of 0. 0. Sorry, multiple of 7. Okay. What do you have? 14. And 21. And keep going. And how about 1? You got like 1 minus 6. And then 8. And then keep going. And then you can try and fill up all this set here. So at least contain 3, 2, 4, 5, and then okay, so you can see that why these two are different even though this element here is different, but the set is the same. So actually we call this 8 and 1 representative. Okay, so you can pick any representative from the set. For example, we also can say that 0, the equivalent class of 0 is the same as the equivalent class of negative 7. So let me write it out. So in this case, A is called the representative of the equivalent class. Equivalent class. Okay. So you can choose different equivalent representative, but on the equivalent class. So this means that inside these classes, 0, 7 is in the relation, 7, 0 is also in the relation, and then transit. If 0, 7 is in the relation, 7, 14 is in a relation, then 0 and 14 is not in a relation. So they all stay inside one equivalent classes. I'm not sure I have told you the concept here. So the concept that okay, maybe we don't want to prove. Do we want to prove? Okay, let's see example first. So let's observe. So observe. So observe that these equivalent classes partition Z. Okay, what does this mean? So that is for every integer, okay, A belongs to one and only one equivalence class, which is A bar. Okay. So for example, in this case, if you pick me a number in Z, okay, I can arrange them into either of these equivalent classes. Okay. For example, if I have 101 in Z, okay. 101 in Z live in which equivalent class? 101 live in which equivalent class? What's the remainder of 101 divided by 7? 3. Yeah, so it will live here. Okay, so every number you take in Z, it will live in either one of them. Okay, so if you imagine this plane here is an infinite plane, so it's Z. Okay, so this is a Z. Okay, so this Z will get partitioned into seven parts. So for example, is parts like this. Yeah. So so it's a 0, 1, 2, 3. Okay, imagine it as then infinitely no boundary. Okay, so equivalent class will partition your set. Okay, so maybe one question for you. Divisibility is not equivalent class, right? So just one example. Okay. N40. What? Okay. First of all, can understand this phenomenon or not? Just get an idea that equivalent class can partition a set. I haven't shown you why it is true, but next week we will prove it. But you need to keep this example in mind that congruence modulo m will partition integers into m partition. Okay, meaning every number will belong to one of these equivalent classes. Okay. Any question on this concept? Any question on this concept? Any question on the concept? No? No. Actually, I think I feel easier to talk this kind of math to you because maybe you already seen some other maths before. If I talk to the first year, I need to like say more so that they can see it. But to you guys, maybe I feel like easier. I just need to say a little bit and you can get it. And get it up. Again, everyone should get this idea. So equivalence class partition and set. If you cannot get it, you should ask now. Because later the concept will based on this. Okay. So equivalence relation. So what do you mean by equal? So you and yourself have to be equal first. If you are equal to the others, the other must be equal to you. If you are equal to the next person, the next person is equal to the next person, then you are equal to the final person. Okay. So maybe where's the attendance list now? Done? Okay. Okay, maybe we have a break until 10:52 and then we come back and then we can talk about some mark statistic on the midterm and then we'll do tutorial. Okay.啊？
就是那个之前不是去那个医院了，然后就回来，就当时没给你请假。
你是哪一位啊？哪一位啊？这个？
我就当时同学来帮我改的。
签。
有人来帮我改，他看到你那个写的 A， 他帮我改了，我就跟你来。
那你不可以这样跟我改，因为我已经填进去了，你要告诉我。你要告诉我。
对，我是那个跟你说。
你发
他之前
你发邮件告诉我，然后我有一个记录。
好的，我今天回去给
你。你上周是整周没有在，整天没有在。
对。我就没敢出门。就是那个全身都是。
OK。
好。那个哦，因为我的头发是面向那个马路那一侧，没有向那个卡塔那一侧。
看一下，会这样改，因为我已经记录了，你这样改。对，你直接跟我讲就行了，我自己会记录。你发邮件给我啊，然后我有记录，下次可以查。
我今天回去。
这个。
对。
啊，
课最后给绩点的时候是会正态分布，就是最后给绩点的时候是会正态分布。
什么叫正态分布？
就是 normal distribution。
应该会吧。
那得4的大概占比多少？
不清楚。Final 也还没出啊 ，quiz 也没考。
就是说，这不是一个就是大概的一个划分吧？就是得4的人占比多少，然后其他人占比多少，是一个 normal distribution。
但是我不清楚。他应该是不要 fail 的太多还是怎样？我忘记，不懂，要看一下，要看那个单词的那个样子。
你觉得这次考试出的难还是不难？
我觉得有挑战性，但不会说特别难。
有挑战性，有挑战性。
感觉前面有一些怎么说呢，就比较基础的东西，然后加了难度，
对对对，
然后就有点搞不清楚。
对对，
因为后面的那些都比较简单。
啊，对，因为你们也没有时间嘛，才2周吧，写那些。
对，
所以我就前面呢会比较那个，后面就比较直接。你是什么名啊？啊，你叫什么？
叫谢景
姓谢啊
，SIE X，
谢景熙啊，OK，
这个程序已经录上去了吗？
录去哪？
就是 load to computer。
有，已经在我电脑里。
今天会发吗？
不会啦，不会公布完吧？就是我会大概讲一下那个 statistic 哦，然后如果你们个人要看，你们就过来看还是讲哦，我应该不会直接给你们看，你们看也没有用，反正那个也不是最终的答案，那只是一个大概嘛。
还有谁要改呢？其他的人要改吗？
比如说可能什么意思？
就是除了你要改那份考试卷子，还有其他
没有，就我嘛，除非
来讲不是最终的，就是那个比的成绩是还没定。
就是比如说其中一个就是你们讲的那个什么续播可能。
可能
呀，那个要续哦。其中一个理由是那个啦，第二个理由可能是我可能会给你们看了，如果你们觉得哪里还可以得分，就再加咯。
我还有 exam unit to shift 那个 final。
他会每次都 shift。
我不知道我也不知道其实，所以我不知道，所以我也不知道。
没有在这边做过老师，
所以我也不知道。
就是如果 shift 的话，就是83，就是第一名直接乘100分。
没有啦，没有，我不知道怎样 shift，我也不知道怎么 shift。
这要看那个 exam unit 的，他不应该会跟我们讲。
呀。
对啊。我觉得他去个半个月去。
你们之前的成绩有被 shift 过吗？
我知道，不知道，没有人跟我们讲有没有被。
他是来从你大概知道你平时考多少，
因为学校只会让我们懂，通常啊，老师只会让我们懂一科，然后final QA
啊，对。
他通常连分考试，我觉得
没有分回去。
有分回去。
有分还是没有
final
就是那种 quiz 啊，还是 test 啊，什么
quiz 我们懂啊，可是 final 然后我们也不懂
啊，
对，就是小，然后有一些是连 midterm 都没有考过的，有一些是连 midterm 就是全部不懂啊，多少分，有一些老师全部没有。
我要问我的那个，看一下那个 midterm 讲给。
然后就最后他就是那个 GPA 直接出来了
啊，
这种最后 GPA，
然后
我们就连分数都不懂，对不对？很可惜。对吧？
Hello. Testing. Okay. Everyone back? Is everyone back? Yeah. Okay. Let's talk about a bit about the statistic. I won't release the mark, but if you really want to know your mark, maybe you can come and see later. But this mark is just a raw score because maybe subject to scaling. Yeah, subject to scaling. I think it's quite
kind of my expectation, the result. The question is quite challenging. I'm not sure how you find it, but I think the question is challenging. Not to say not doable, but challenging. The exam, the average is about 54. Average is 54. 54, yeah. The highest mark is 83 and 10. Okay. Although your school is like above 85 is A, right? For me, for my test, I think above 80 is okay. Or 75 above, okay. But for above 80, we got like 5%. Yeah, in your class, you got 5%. Around 80 to 83. Right, 80 to 83. If I don't record my mark wrong, okay, 5%. So one of them is陈董金啊，陈董金，yeah, okay. Second one is 郭一飞. Okay. That's good. And then 赵子豪. Who is 赵子豪? Not here. 张子豪, okay. Who is 张子豪? Oh, okay, congrats. 郭春麦. Oscar. Yeah, others you can work harder. Okay, I got a lot of support for you. You should come and find me, look for me. If you don't know the concept. Okay. The standard deviation is like, oh sorry, it's actually 17. 17. So it's like about 2 question error. So either you know how to do 2 questions, either you don't know how to do about 2 questions. Standard deviation. Okay. Yeah, we still got final and then quizzes. More quizzes. Yeah. So there's a double pass through in your course, right? So you need to pass 40% of your midterm and quizzes, and also 40% of your master course. Okay. Anything else you want to ask? Anything else you want to ask? Borderline, got borderline like 79, 78. If the borderline, I see borderline, Wang Dong is here. Is Wang Dong here? Wang Dong. Not here. Wang Dong. Is Wang Dong here? No. Who is Wang Dong? Huh? Wang Dong, eh? Where is Wang Dong? Wang Dong not here. Not here. Huh? Wang Dong not here. Yeah, one of them is Wang Dong. And then Wang Dong not here. Okay, you got 3 chances to come absent without reason. 3 chances. You can, I mean, you can distribute your 3 chances. 3 chances for below 3 chances, then less than 80% you cannot go exam. You can distribute your 3 chances. Maybe today you're too tired, you don't have time. Yu Su Yang. Who is Yu Su Yang? Yu Su Yang, yeah. Borderline. Maybe after, if I can give you back, you can check. Maybe if you think you can earn more marks, then we can adjust the marks later. After all the exam done, all the replacement is done. Chris Nandi, yeah. About 88, 80, 78, 79, then Daniel Tan, yeah, Daniel Tan. Okay, yeah, that's about it. Okay. Yeah, just frankly speaking, you got 3 chances to come without reason. You don't want to tell me or what. But after that, then you should just let me know if you cannot come or what. If the reason is acceptable, I just put you E on it. So you don't need to lie to me again. But if you really don't want to come, then it's on you. If you got reason, you just email me. Okay. You just email me, then I can let you go. Okay? No more questions on the score, then we will start the tutorial day.
应该是最后
会有啊，会这是 raw score 啦，
讲
还会再调。对，这是暂时，之后会 subject to scaling 啊，或者再检查什么的。
subject to scaling 的意思就是这样，
整班
整班好像如果最高只有83，那会调
差不多，或者看 fail 啊，或者看什么这样，我也不知道。
老师，我有一个历史问题要问，可是因为我之前没有试过后啊，因为很多就是从 topic 1到 topic 2有一个历史问题。
我们现在才问考完了，
因为然后就是有一点点，那时候要考试之前那个周末有事情做，然后在学校。
可以啊。
还要找一补习压力非常大。
可以啊。
你老师。
溜啊，姓溜，LIW，这只是 raw score 罢了。depend 哦 ，depend 整班的那个 performance。溜什么？这个。你是什么名？苏啊 ，SU，这个63，最好是。 ？raw score 不了，这 raw score。你什么名
谢
？SIE。
对 XIE。
等下等我找一下，等我找一下。谢。不错。
张成生不到钱。
都是。哎，一个一个来，一个一个来，一个一个来。
我能在网上来翻啊，
谁？
谁？
这 raw score 不了啊 ，raw score 吧。
是陈东进看的，
他叫我
看的，他自己叫我看的，他自己叫我看的，真的哦。还有我嘞，我操
！180。
好。
哎，一个一个来，一个来，一个来。你？
别看别看我看。
一个一个来，一个一个来，一个一个来。
慢点，再看我。
1 by 1。好吧，你就走了。
我操，怎么这么多人？
一个一个来，干嘛？一个一个来，一个一个来。
我他妈吓人啊！我操！哎，不是一个个来。
你叫什么名呢？
哦，那个 X。
这个 X。徐艺晴啊。
一个个来，滚蛋！
一个一个
来。是你旁边你的。
你知道紧张。不错。
哭了。
可以。这是 raw score 吧？
快点滑上去。
看谁要看谁？哦，答卷慢一点，因为还有人没考。对。哎，可以。raw score 吧 ，raw score 吧。raw 的 raw。
老师可以再整齐一点。
谁？
李舒阳。
李舒阳对。李舒阳。
这能调到80。
对呀，等再看一下那个答卷。什么？对，你先那个。
他是。
罗一飞。
是你刚划掉我。耶，我是84。对，小提分可以看。
你什么？
下面。
C。
小提分的。有了，可以画上去吗？那小提分等答卷了。
一个来而已，一个来哦。
说我看一下099农具
啊，
看一下农具21090999。OK， 谢谢。是吗？
你是谁
？A 09930。
9930。09930。935。935。刚好在下面。
我看我有个82吧。
是吧？
有啊，谢谢老师。
他说看我21090604啊，这上面几个报
9604
啊
604啊
604这上面。OK，Thank you。
这是开107，开
107。单词好。你多少？
这就往后翻就行。
你是谁？
我大概看。
你是谁？你告诉我你号码。快点告诉我号码。快点。
不知道。
谁是你？快点。
87。
087。
哎
，7还是8889？
一乱
啊？
一乱。
这有几个报纸啊？
呀，我知道你应该是79。
我差一个，他在那边。
警察
下面一点的。
你是谁？
丢
丢加签。
64。
那是 raw score 吧？
什么是 raw score？
就是说可能 subject to scaling 啊，然后之类，
会加的。
应该会加的，会加。你几号？你学生号是什么？你学生号是什么？你学生号是什么？我看一下。后3个。60。差得多吧？预警，加油加油！这个哈，这是这个 raw score 吧？还可以换的，还可以调 subject to scaling 哦。要看多少？
要长红色牌，
你学生号
093、093和094。
怎么有2个的？你是3？
哦，我是3。
你朋友是4。
没有对，
这只是 raw score，raw score，就是可能会调，看到保证不要 fail 先。上70分有多少个？差不多11耶，11。哎喂，13。
3个。
你要找什么名？益阳、子阳、益阳还是？
哎呀，老师别看我，别看我，看到他。
谁看谁？谁要看现在？
看你上面。
你什么号码
097。
097。这只是一个基本分啊。
就是它是分基本分和什么分的？
就是可能还会再调啊。
那就差不多就是这个。哦。
应该不会再调低了。你呢？子阳
下面不是很敢看。
子阳啊。
怎么才6分吧？
慢点看一下那个好线。
完了，好难受。
慢点看一下稿件。
挺难受。
感觉预习了这么久，结果还是
预习很久。预习多久？每天都在预习。
差不多吧，就是考前基本上那一周都是周末都是废的。
可能给你做2、3个 AIT 210960。
有问题要来找我。
问了呀，算了呀。等我一下滑。
你耶？你叫什么？学号？
高9080。
080。908。
9080。
9080080啊。是这个吗？080。
对。
对，哦，这个叫明豪，安塔西啊，CHAN 啊，N 哦，这边啊，这个没有来啊，没有来啊，
没有啊，
OK，
没有。
你做考卷的时候觉得怎样？
觉得题会很多，而且有比较多是tutorial 没有了，比 tutorial 难很多。老师说，
可是你是做的，I mean 你做的时候是来，
我是觉得有 related 上课的东西，就是比起 tutorial 更多的是来，本来在这边课可能 maybe 它是一个 theorem，but then 要你 apply 进里面去。
对对对
这种感觉，就做了是那个情况，然后跟他一起，还可以，对。
Yeah.
Disco session just
See mine. Oh, 57 good lah.
This one okay.
so I expect 30 only, but intern.
Intern.
Yeah.
Go up.
Intern.
Okay lah.
53.
Yo,
Mine.
yeah,
All the way down, sir.
yeah, 40 already, I happy. I know, bad. Oh my god. We some no study also still can be there.
You're Indonesian. Indonesian. Only
会讲华语。
Okay.
那个100
啊
？Benefits of praying in
谁是109？不是你啊，你朋友，你同学，他没来。他没来。告诉他跟我讲，他没有来。如果他没来，叫他email我。谢谢你。
跟他才感性。
对啊，Eric。OK。
那9多，那最后3个是9人。
哎，45不是他。哦，这个 Eric 他没有来吗？没有来。你家
在前面。
要看同学。
啊，对，帮同学看。
所以
776和78 9076，应该在最上。
076。2个都没来。2个都没来。
不是来了，不太愿意上来看。
在哪里？
在后面。
在后面。
会再考，会再考。哇，那啥，这个很离谱。这个菜的为什么会有很大？我没看到这一款资料哎，我百说说的感觉那个同学是内买吧？应该吧？然后秒那个。
嗨。没有。那就下周做。下周做。
然后为什么没有那个 relation？
下周做。我怕了太多题了，因为 counting 的概念容易，但是题目不同，很多不同。
真假？
Actually, I want to ask Ethan. What do you think about the exam? And see the question, what do you think?
There are some extra time, so I go back and the questions that I didn't.
Okay. How you feel about the difficulty? What? What? And what? Can be solved. Okay. It's my comment. Anything? Nothing. Nothing. Okay. What time?
这个机的，
可能ยัง
一派，
นิ่งทางต้องลิงก์ตรงจริงไหนตรงลิงก์
very challenging.
very challenging so very challenging how you get 80 อ่ะ
Yeah. Yeah, go.
This was
I can hear.
huh?
I can do it.
You can do it. Okay. Good mindset. Okay. Yeah. Very good. Yeah. Actually, okay. Actually, I see Chung Wai, right? Chung Wai remind me of the when I study in Australia. So they also don't bring back one. They don't bring back to study. They just go in and listen. And then during the tutorial, they just talk. And then, okay, some of them is good, but some of them is like just talking. Yeah, so why this kind of model will work? What I observe is when you go to class, you should understand the concept instead of learn all the words. For example, I introduce one concept, you should convince yourself that concept. Maybe you will forget, but once people touch on that concept, you will automatically get the picture. At least what I think is like that. So instead of like, that's why like they don't bring books or iPad or anything, but they seem to know something. So it's about concept. You learn the concept. For example, maybe you don't realize like the traffic light. Traffic light got 3 colors. Why you already know that red is stop, blue, green is go, and then yellow is prepare to stop. You don't need to memorize. This means you already internalize, you already understand it. You don't need to memorize. There's 3 colors if you need to memorize, right? But it's like become a natural thing. So this is like how you absorb new knowledge. Okay. So if there's something you are unknown when I introduce the knowledge, you should straight away point it out and then clear your doubt, and then you can keep going with your logic, your own logic. Okay. Instead of like understand it by heart. There's some advice from what I learned. Okay, so let's discuss 6.1.2 first. So 6.1.2, an office building contains 27 floors and has 72 offices on each floor. So how many offices are in the building? One floor got 37 office, so just multiply by 27, you get all the office. Use product rule. 6.1.26. How many strings of 4 decimal digits 8 do not contain the same digit twice. So that means you got 4 decimal digits, 10 possibilities, and then cannot repeat. So once you pick 10 choices in the first phase, and then you left with 9 and then 8, subsequently 7. Begin with an odd digit, so only one place got restriction. Hey, did I read the wrong one? Okay, 26 even digit, end with even digit, so only 5 choice, so 5, 2, 4, 6, 8, 0. And then the other is free, so top 3. Exactly 3 digits that are 3, there are 9. So either 99 something or 99 something 9 or 9 something 99 or something 999. So there are 4 ways, and then you left with 9 digits. Cannot put another 9, you must exactly 3 nines. 6.1.28. If I'm going too fast, you can stop me if you want me to repeat. How many license plates can be made using either 3 digits followed by 3 uppercase English letter or 3 uppercase letter followed by 3 digits? So 3 digits followed by 3 English letter, mod 26, or 26 English letter plus 3 decimal digit. So you first use product rule and then you use sum rule. 6.1.50. How many bit string of length 7 either begin with 2 zeros or end with 3 1? So you got 7 length 7 string. Either you start with 2 0 and either you end with 3 1. So if you start with 2 0, big string only contains 0 and 1, right? Bit. So you have 2 choices in each place. Similarly for the end with 3 ones. But you need to know that when you compute all the possibility, if you add up these 2 possibility, actually you double count the 0 0, then the string that start with 2 0 and end with 3 ones. So you need to take away this possibility as well, which is 2 times 2 is 4. And use the inclusion exclusion protocol. 6.2.2 using the pigeonhole principle. So that if there are 30 students in the class, then at least 2 have last name begin with the same letter. Okay, so because letter you only have 26, now you have more than 26 already. So by pigeonhole, you have you can prove that there's at least 2 have the last name that begin with the same letters. Actually, you only need 27 is enough to have at least 2 students with the last name begin with the same letter. 6.2.6. So you got 6 professor, and then the marks is from 0 to 100. And then what's the how many students must there be to guarantee that there are 2 students with the same professor who earn the same final examination score? So you need to determine how many holes first, how many boxes. So you got 6 professor, and then you got 101 marks, different marks from 0 up to 100. And then you multiply together, actually you got 606 holes or boxes. And you just need to make sure your student is at least 607 and pass 1. Then 2 of them must have same score from the same professor. 6.2.20. Okay, this one will be interesting. So if I tell you only 9 students in the class, why can I deduce that there must at least 5 males or at least 5 female students? Yeah. One way to do it, you can use contradiction. So if they are less than 5 male and less than 5 female, which is 4 plus 4, less than 4 plus 4, which is 8, then you cannot have 9 students in class. So it's contradiction. ADB must have at least 3 male students or at least 7 female students. So if you are less than 3, less than 7, which is 2 plus 6, is also 8. So it's contradicting. We have 9 students. Six point three point four. 6.3.4. What do we have? 6.3.4, just listing out the 3 permutation of the 5 elements set, and also list out the 3 combination of 3 element set. I already counted. You can list it, but there are so many choices, so you can just count and then try and write out some element to see that, to convince yourself this number. And then 6.3.14. In how many ways can a set of 2 positive integers less than 100 chosen? So you just chose out of 99, you just chose 2 positive integers. Okay. So it's the 99 just 2. 6.2.2, what do you have? 13 people on the softball team show up for a game. How many ways are there to choose 10 players to take the field? So 13 choose 10. So how about B? V, how many ways are there to assign 10 positions? Okay. So 10 positions is important, right? So if you change the position, then it's a different team. So you use P. Okay. So who is the shooter? Who is the defender? Who is the runner or what? Okay, C is a bit different. So of the 13 people who show up, 3 are women. How many ways are there to choose 10 players to take the field if at least one of these players must be a woman? So at least one of the players have to be a woman. Actually, we can use part A. So if you pick 10 person, at least one have to be woman. There's only one way to get all men. Yeah. So you can just minus 1. Why? Because 3 of them are women, right? So only 10 of them are men. And then one way to pick this 10 of them is 10, like one way. And so just use A minus 1. Because the question changed to 13 of them, 3 are women. So only one way to pick this 10 men. 6.4.2. This one is repeat my argument in my lecture. Repeat the argument in my lecture. So try and convince yourself that my binomial coefficient is a combinatorial reasoning. So if you write out the expansion, okay, you can try and find all the possible way to write x5, x to the power 4, y, x cubed, and y squared, x squared, y cubed, x, y to the power 4, and y to the power 4. Okay. Write out the different way you can find it on the S product. And then the other way is just use the formula. Six point 4.8. Yeah, this one is application already. You see, here the monomial is different. Okay. So, but when you multiply together, your coefficient also scale up by this power. And then how to get this coefficient here? You just use the binomial coefficient. Okay. And then this will scale up relatively with the power of SZ1. Yeah, that's all. Okay. That's all. Yeah, so next week we'll do more on the equivalence relation. See you next week.
这个是下周发下来是总共吗？或者是批改？
看一下咯，看一下，可能要等那个他们考完还是怎么
等他们就是第二步审核完。
看一下，再告诉你。
对啊，
好，老师，哎。
paper 啊，这样分回来给我们 paper 还是还是不会再分？
会，应该是会，要安排一下。
哦，所以差不多 maybe next week or week after 就会再拿回来。
depend 咯 ，depend 那个 replacement exam 还是怎样。
replacement
因为有人还没。
哦。
Thank you，那也是老师。